A black hole shouldn't be able to give anything back. Nothing escapes a black hole. That's the whole point. But scientists just built a machine that proves one of them can. And by the end of this video, I'll show you the strange trick this device uses that doesn't even require anything to physically spin, a detail that stunned the researchers themselves. For over 50 years, this stayed a chalkboard equation, a brilliant, half-believed theory nobody could test. Then a team at CUNY finally built it. And what they found changed how we think about the most violent objects in the universe. Here's how a black hole can leak power, and how humans just captured it right here on Earth. In 1969, physicist Roger Penrose proposed something that sounded like science fiction. Around a spinning black hole, there's a region called the ergosphere, where space itself gets dragged around by the black hole's rotation. Penrose said if a particle entered that zone and split in two, one half could fall in, while the other half escaped, carrying more energy than it started with. Energy created from nothing but the black hole's own spin.
Soon after, physicist Yakov Zeldovich pushed the idea further. He said you wouldn't even need particles. A wave alone, bouncing off something spinning fast enough, could steal energy and come back stronger. But there was a problem. To see this effect, you need something spinning at nearly the speed of light. No lab on Earth could spin actual matter that fast. So for decades, this stayed exactly where it started, trapped on paper. So how do you test a theory that needs impossible speeds? You cheat. Researchers at the CUNY Advanced Science Research Center built a ring-shaped device using engineered metamaterials, structures designed to bend and steer waves in unnatural ways. Instead of physically spinning a disk, they modulated the device in space and time to fake ultra-fast rotation, creating the illusion of motion faster than light without moving a single physical part. Then they sent radio waves in. Waves with the right rotational pattern didn't just pass through. They pulled energy from the system and came out amplified, stronger than when they went in. According to the researchers, this reproduced the essential physics of the Penrose-Zeldovich process, published in July 2026 in the journal Nature. This wasn't the first hint either. Back in 2020, a University of Glasgow team ran a rougher version using sound instead of light, a spinning foam disc and a ring of speakers, and caught the same fingerprint, sound waves shifting in pitch and amplitude as they passed through the spinning disc. Two different setups, two different eras. The impossible theory finally brought to life in the lab. Let's be clear about what did not happen here. Nobody built a real black hole. Nobody captured energy from an actual object in space.
This is an analog, a stand-in system built to obey the same mathematics. The same way a wind tunnel isn't a hurricane, but still tells you how a hurricane behaves. But that distinction almost makes it more useful, not less. Real black holes sit trillions of miles away, spinning at speeds we could never approach or measure directly. This device sits on a lab bench. Researchers can tune it, break it, rebuild it, and watch the effect happen on command. That's the real prize here. Not power, insight. A repeatable laboratory window into physics that used to belong only to the most extreme regions of the cosmos. And the researchers are already saying this same approach could help control light in new ways and open doors in optics and quantum technology that had nothing to do with black holes in the first place. So no, we're not plugging a power plant into a black hole anytime soon. But for the first time, a 50-year-old idea about the universe's most extreme objects just got dragged out of the equations and into a working machine that hums on a lab bench.
If black holes secretly leak energy just by spinning, what else have we been wrong about? Drop your best guess below. And if this bent your brain a little, the video on what actually happens if you fall into a black hole is exactly where to go next.